Hi, welcome to Learning Monkey. I am Raghu here. In this class, we'll discuss about how to show the given proposition is tautology or not without using the truth table. In our last class, we showed equivalence of two propositions without using the truth table. That is the first practice example. Please watch that class and come back here. The link for the playlist is provided in the description below. So coming to today's class, this is the proposition which we need to show this as tautology. By using truth table, it is very easy. Construct the table. If you got all truths in the end, you are going to say it as tautology. But without constructing the table, we need to show it by using the equivalence formulas which we discussed in our previous classes. And in our last class example, slowly we clearly explained how to reduce the given proposition. We can reduce these propositions, how to do that, how to think about that. These ideas have been given in our previous class. Our assumption is you already have that intuition. We'll go a little bit fast here because our assumption is you already have that intuition. So coming here, if you want to show this as tautology, the first idea you need to get into your mind is, so if you reduce this equation into the form negation P disjunction P or negation X disjunction X, which is always true, we can say that you got an equation of tautology. So from this idea, you need to reduce this equation in the form of negation X disjunction X. Now how to reduce this equation in this form? Now assume that P conjunction Q implies P disjunction Q. So from the implied statement, P implies Q can be, you take this as X, X implies, take this as Y. X implies Y can be written as negation X disjunction Y. Yes, we can write this as negation X disjunction Y. See here, P disjunction Q disjunction conjunction. This is a different symbol. All are same symbols except this. But from this equation, when you look at this equation here, negation is there. Means from the De Morgan's law, if you take a negation inside, conjunction is going to convert into disjunction. So every symbol is converted into disjunction. We are trying that. So when you take this negation inside, negation P disjunction, negation Q disjunction, P disjunction Q. So what's the point you have to get into your mind? All are same symbols. You can apply associative law. You can place these brackets anywhere you needed. That is what associative law means. Whatever, all are same symbols, you can place anywhere. The equation is, the total equation is same. You can place the brackets whatever the way we required. So negation P, P, we are making it as one bracket. Negation P, disjunction P, disjunction. Negation Q, Q is making it as another one. Negation Q, disjunction Q. We know that from the basics, negation P, disjunction P means true value. Disjunction, negation Q, disjunction Q means true value. T disjunction T means T. So finally we reduce this equation into T, which we show it as tautology. Always you are going to get true value, means that's why we say it as tautology. This is how we need to reduce. Let's take one more difficult example so you will have a better understanding. Show that the given proposition is tautology. So this is the entire proposition. If you are having this type of propositions, always try to reduce these propositions into parts so that you can solve them easily. See here, we are considering this as one part, P disjunction Q, conjunction, negation of, up to here one equation. We are considering it as second equation. Similarly, we consider this entire thing as third equation. So always try to reduce, first reduce the second equation, then reduce the third equation, then join. We check that, this is how we need to check. Let's take the second equation. This is first equation, this is second equation. Let's take the second equation, negation of 4 brackets, negation P, conjunction brackets, negation Q, disjunction, negation R. So this is written like that. If you take this negation inside, first get rid of that negation inside by using De Morgan's law. This conjunction will become disjunction. So negation of negation P, disjunction, negation of negation Q, disjunction, negation R. Again we have the possibility, if you take this negation outside, means from here to here, or you take this negation inside, you will get this disjunction as conjunction. This disjunction is going to be converted into conjunction. So this negation P is going to get cancelled. Negation will get cancelled. So this, if you take this negation inside, negation of negation Q, conjunction, negation of negation R. Negations are going to get cancelled. We will get the final equation as P disjunction Q conjunction R. So from this different symbols, always apply distributive law. P disjunction Q conjunction, P disjunction R. So from the second equation, the final equation we got from second equation is, this is the equation. So what is the first equation? This is the first equation. First equation, disjunction, conjunction. Second equation, what's the second equation? We got this. So combine those two. First equation, conjunction, second equation. See here, when you look at it, P disjunction Q, P disjunction Q. In between, conjunction. So X conjunction X, you can write it as X. You can remove one P disjunction Q. You can remove one X. X conjunction X is always X. So these are the basic formulas which we discussed previously. So removing one X, we are writing the entire equation as P conjunction, P disjunction Q conjunction, P disjunction R. So from the first two equations, the final equation which we got is this one. Say this equation as E. Now let's take the third equation and try to reduce this. So if you take the third equation, this is the third equation, negation P conjunction negation Q, disjunction negation P conjunction negation R. So by applying De Morgan's law, take the negation outside. This conjunction is going to convert disjunction, negation of P disjunction Q, disjunction, negation outside, P disjunction R. So this is what we got. Again this equation is in De Morgan's law. Yes, see, you consider this as X, negation X, disjunction, negation Y. If you take the negation outside, this disjunction is going to convert it into conjunction. So if you take negation outside, P disjunction Q conjunction, P disjunction R. This is equation F. So from the question, first, second equation, disjunction, third equation. First, second equations are reduced to E. In between, we have to write disjunction and apply the third equation. This is the third equation. So this equation we call it as F, E disjunction F. So from these two equations, you understand it properly. P disjunction Q conjunction, P disjunction R. P disjunction Q conjunction, P disjunction R. Same, but here we are having negation. You consider this equation as X, this equation as X. X conjunction negation X, which is always true. So finally we showed that the entire equation is reduced to T. We say it as tautology. This is how we need to use the equations which we discussed in our previous classes, and we have to reduce that into true. Then we say it as a tautology. Hope you understand these examples. If you have any questions regarding the concept, please post your questions in the comment section below. Thanks for watching. If you haven't subscribed to our channel, please subscribe to our channel and press bell icon for the latest updates. Thank you.